Hey everyone, we're in Taiwan at MSI's headquarters, and the first part of this tour is going to be the EMI lab. So we're looking at a few different places at MSI's HQ in Taiwan, and we have a clip from the acoustic testing room. We have another room, an SA room that we'll look at, and we wanted to start here at the EMI lab because it's really interesting stuff. Before that, this video is brought to you by Be Quiet and its Straight Power 11 series power supplies. The Straight Power 11 PSUs ship from 450 watts up to 1,000 watts, accommodating most of the gaming PC build requirements you'd encounter, and focuses on delivering a higher quality power supply that doesn't sacrifice on efficiency or stability. Noise is also a heavy point for the Straight Power 11, using a 135mm Silent Wings 3 fan that can spin as low as 200 RPM for quieter, low-load operation. Learn more at the link in the description below. First of all, you'll notice the paneling is sort of similar in some ways to an acoustic room, like a semi-anechoic or anechoic chamber, except this is used for radiation testing instead of acoustic. So in this instance, there's the foam paneling on the walls, there's metal paneling on the wall behind that, and this is set up all for absorption to reduce the influence of bounces from radiation or from EMI on the antenna behind me. And there are two types of antenna used where, so one of them here is a smaller horn antenna, and the range on this one is 1 gigahertz to 6 gigahertz for the signal that it's looking for. The larger one here can actually move up and down, and we have some footage of that too. And it's used for CE compliance testing. So you have different standards around the world depending on where you want to sell your product, and they have to comply with different radiation or EMI, electromagnetic interference standards. And so CE is one of those. And MSI complies with the CE standard. So it has to push its components through testing to make sure that it meets those standards for EMI. And what MSI is doing here is testing a full system. They have ways to isolate for individual components. So if they want to isolate for their VGA or for their motherboard, they can test to ensure that those individual components meet the spec. This is all pre-testing, it's pre-validation. So after MSI goes through pre-testing with their components here, they take the component, send it out to another lab, third-party lab, for official final specification testing, making sure it's compliant so they can receive the CE badge or whatever badge it may be. So the antenna on the other side of the room, they receive direct radiation. The paneling around the rooms ensures that there's no sort of amplification, no picking up of unnecessary noise, unnecessary radiation. It's just direct feed from the system under test or from the DUT. And so there are different test patterns. The one that's on the screen right now is actually a VGA test pattern. They generate some kind of load for the system or the device under test, and then that's fed through a system that we can't show you, unfortunately. But there's a system outside of the room that reads all of the what the antenna is picking up. And so then MSI can validate if it's meeting their spec. And so the spec that MSI uses is a -6 dB, which is actually lower than what they have to meet. So when they send the system out or send the component out for further validation, there's some headroom there just in case there's a difference in how the chambers are set up in different locations. And speaking of the chamber setup, so this whole room is special built for this. We have a shot of the door opening too, if we haven't used it already. And the door is a giant metal door. There's metal paneling all on the outside of the room, metal paneling in the whole inside of the room. The corners of the room are very specifically angled as well with metal panels, so it's not a flush corner. And then you have foam paneling here, foam paneling there, the antenna, of course, and everything else in the room. So total room cost for something like this is somewhere between maybe 20 and 30,000 USD, somewhere in that range. But it's very important to ensure CE compliance and ensure that the designs are good. So if MSI has any issues with EMI, they can pick it up here, improve the design, and then test it again to make sure it validates for compliance. So this is used for testing VGA, testing motherboard, any other components MSI might make, and then the system under test is here. This actually table can rotate, so all the cables are hooked up, plugged into the table in the center, and then that's plugged in elsewhere, and the cables are passed through the wall and insulated as well. So pretty cool. We have a shot of it all rotating as well, so they can detect, they can pick up EMI from different angles, make sure everything is within spec no matter the angle the system's at. I think that mostly describes this room. Oh, and they can also switch antenna on the big moving one, so the MSI can change that out and use a different type of antenna if they want. And also, You might wonder what the net's for up there. It's just strictly for safety. It doesn't do anything else but in case something falls down. So there's a lot of sensitivity here where if you're testing in this lab, you have to put your phone into airplane mode because the machine will actually pick up that EMI, that electromagnetic radiation or interference, and it'll pick up on the graph and cause a big spike. That isn't obviously from the system. So I think our sound recording equipment doesn't create too much EMI, but that would pick up as well in theory, and it's all very controlled as a test environment. So that's the EMI lab. Let's move on to one of the other ones, maybe the acoustic lab next. You're going to hear my voice change in that one because it's a semi-anechoic chamber, so you'll hear my some of the bass will be removed, and it's a pretty cool experience. So for this room, probably the audio and the video, my voice will have changed at this point. We're in a semi-anechoic chamber. We filmed these before. We did one at Logitech's years and years ago, and this is MSI's semi-anechoic chamber. So it's actually pretty cool the way these work, and you may already know some of this, but these big foam blocks, of course, used for, I believe in this case, it's absorption. There's a few different ways you can deal with sound. So in a PC case product, you might do absorption or like a deflection, basically, where you just kind of bounce it around until the sound wave dies, loses all of its power, or you can absorb it, and there's a few other methods too. But for a room like this, I believe they're doing an absorption approach, and the idea is to get the noise floor as low as possible so that when you're testing the products, you have more room to scale your testing, your test resolution. So for example, when we do noise testing on cases in our lab, we don't have the budget of MSI or Logitech, so our noise floor is about 26 dBA, which is pretty low. It's good for a quiet room, but this will get you much more accurate results because your range for the scale of noise that a product will output is expanded. So when we test stuff, we can't bring our test resolution below 26. It's not possible because the room is louder than that. The noise floor here is about 16 dBA, and this is set up so that there's padding around the whole room, including the ceiling. We have some shots of. And the padding's mostly just this stuff right here. In 2 corners, there's slightly changed foam blocks that are more square, and that's just to deal with the deflection in the corners because you're dealing with noise bouncing between 3 adjacent surfaces, the walls and the ceiling. And so those blocks change to deal with that noise in an appropriate fashion. In terms of testing, so right now MSI has one of their cases set up in here. MSI also does notebook acoustic testing. They do testing for customers. And the goal is to check from these 10 different microphones in the room what the noise levels are, typically testing from the front from a user scenario. So where would the user be seated realistically versus a notebook, and test the noise output of that device. And so that's the basics. The really cool thing with these anechoic chambers or semi-anechoic chambers is always just how insane the change in type of sound is. So when we start our videos, we do a clap to synchronize the audio on the camera and my mic, and I don't know how well that carries through in video, but we'll do one from somewhere else that's not an anechoic chamber, and it just deadens the sound immediately. It doesn't really feel like it travels and bounces like it would in a normal room. The foam even extends to the doors. So there's 2 doors. One of them has big foam blocks on it. There's foam between the door and the wall, and then there's a second door as well. So any point of entry is thoroughly deadened by more foam. So pretty cool stuff. The testing here, MSI looks at frequency, so they can look at the type of sound in terms of frequency, looks at the dBA output. There's some isolation under the floor as well, by the way. We're not sure exactly what it is, but to help with noise further. And then this, as far as the ISO standards go, complies with 3744 and 7779, which I'm not specifically familiar with, but there's ISO compliance so that MSI can do testing for partners and meet those standards. And then the dimensions of this room, so it was built, it was sort of added on for MSI, and the dimensions, outer dimension of this room is 5.4 meters, 5.4, and then 4.15 meters. Inner dimension's a bit smaller, counting the foam blocks. It comes down to like 3.5 meters, mostly, well, squared plus 2.7 meters. And if for other specs, the cables are patched through the wall, through foam blocks, and the point of that is just to further isolate the noise, because you have to get cables in here to plug into the devices. So running them through the foam, through the wall, will ensure that there's minimum sound getting in through the walls, through any potential holes. So pretty cool setup. And if you want to see more of stuff like this, we do have an old video tour of the Logitech sound anechoic chamber as well. And I guess I'll also note that temperature and humidity is controlled in here, so we have some shots of dehumidifiers, things like that. An AC unit that I wish was on right now because it's pretty hot in here. So, but let's move on to the next lab. So this is the acoustic lab. Really cool stuff from MSI. We're going to check out one of the other ones. EMI or SA will be next. The last MSI lab that we're looking at is the Signal Analysis Lab, or SA Lab. MSI's electrical engineers use this lab to ensure motherboards and video cards are able to produce clean signals that land within the specs of the associations that set them. So that would be things like DisplayPort, VESA specs, and HDMI requirements. Testing is also conducted to ensure USB ports on motherboards meet the USB-IF requirements, or that SATA ports meet SATA standard requirements, but MSI has its display testing hooked up for us today. Each device is connected to a series of probes that connect to different scopes, which then measure the signal through automated testing. Engineers are able to view a full lab report at the end of the test and see if the device failed any tests, and if it did pass all of the tests, the engineers can prepare the video card or motherboard to go out to the authorized test centers or third-party validation labs to receive the certifications needed for DisplayPort, HDMI, or other standards. The first test station is outfitted with a Tektronix DPO71604C. It's a high-end oscilloscope that's a digital phosphor oscilloscope that looks at a signal on the time domain for less than 11 hours when validating for Compliance Test Standard version 1.4, or CTS 1.4. The compliance standards are provided by the various display groups or other interface groups, depending on what's being tested, and must be met to ensure that the device and its video output surpasses all of these standardized tests. This includes video cards and motherboards alike. There are eye pattern tests, for one example, where the signal output produces divergent and convergent patterns with specific amplitudes. A single test failure would mean one of the features of the device has failed and has to be improved, potentially by rerouting circuit traces or redesigning the PCB or updating firmware. MSI is experienced enough with this type of testing that there is rarely a failure of this type, but if there is one, MSI is equipped to look at it and figure out where the failure occurred and then fix it before any kind of public launch. On the Tektronix DPO71604C scope, MSI currently has 4 differential probes hooked up that each accept a pair of wires coming from a DisplayPort connecting into the special header at the back of the video card for signal analysis. There are 4 pairs of differential signals coming out of the DisplayPort that need to be tested, which is what we're looking at here. The scope captures the signal and uses an auxiliary board positioned next to the blue wires, which automates testing and runs through pre-programmed test patterns and sequences to individually benchmark the signal for all CTS 1.4 requirements. As for the green probes, these are SMA coaxial probes that are meant for the same type of task, but just used for their different bandwidth capabilities. MSI also has a customized PCIe testing board that is used to balance the PCIe signal. This board validates PCIe electrical compliance testing and quality circuit trace design for the PCIe capabilities via the video card. The board can connect either via PCIe by 16 or by 1, depending on the test, and has groups of probe connections for each standard. For PCIe by 16 testing, 16 pairs of data lanes are connected to validate the signal, producing a mountain of data that engineers have to use to ensure signal quality. This compliance load board has dip switches for PCIe generations 1 through 3, and it will eventually need a switch for PCIe Gen 4, but MSI can't presently talk about the new interface. As for the Tektronix oscilloscope used, the one we mentioned earlier, this cost MSI about $25,000 USD originally to purchase and configure for testing, and it's not even the most expensive scope in the lab. The next battery of tests comes from the network analyzer, which is focused testing on PCB impedance and S-parameter measurements. For these tests, MSI connects differential TDR probes or phase-matched stable coaxial cables for measurement of impedance or insertion loss or return loss from the device under test, or DUT. These tests first have to be calibrated, which can be done with automation fairly quickly or manually over the course of a few hours, and then MSI connects the probes to the DUT and adjusts signal pitch according to the signal traces. Finally, MSI's most impressive test equipment is one which tests signal receiving, validating that the signal output is the same as the one that is received or sent in a loop. This test is exhaustive and has strict requirements for accuracy and can be used for display outputs, SATA, USB, or other connection standards. For example, in one test pattern that wasn't running when we visited, PCI SIG requires that of 10 to the 12th bits transmitted and received, only a single bit can produce an error in order for the DUT to pass PCI SIG requirements. This tests that the output signal matches the input signal on the other side, looping back into the oscilloscope for validation. For perspective, this equipment cost MSI about 2 times as much as the earlier Tektronix scope we showed, and is one of the most impressive pieces of validation hardware we've yet seen on our tour. That's all for this one. As always, subscribe for more. Go to patreon.com/gamersnexus to help us out directly, or store.gamersnexus.net to pick up a shirt or one of our mod mats. Thanks for watching. We'll see you all next time.